Hello YouTubers, I discovered some good data on Bigfoot. While I think it's unlikely that Bigfoot exists, I'm also willing to look at the evidence, and so I decided to create some videos on mapping and analyzing Bigfoot reports. Despite my skepticism, mapping Bigfoot reports revealed some rather interesting trends and patterns. I approached the issue by asking two simple questions. The first question is there anything in the dataset that can help me determine whether Bigfoot exists? And the second one is, if Bigfoot exists, where would I most likely find him? Upon downloading the data, I used Excel to clean it so that I could have a data set sufficient for analysis with minimal error. Thankfully, this is a fairly good data set, and little was needed to be done except for filtering and removing unwanted entries. Several of the entries did not have coordinate values associated with them, so I filtered and removed those entries. Additionally, I decided to filter Bigfoot reports by season and create a separate file for each season. After the Excel files were created, I used ArcMap to create XY points of the entries and create a shapefile of the point data. I ran cluster, outlier, and hotspot analyses, plus calculated the standard deviational ellipse and geographic mean center to map and analyze all Bigfoot reports where the incident occurred during the springtime. Additionally, I created a separate shapefile for points that contain the attribute Class A, since these reports are direct sightings. The tools were then ran on the Class A point data and mapped so that the maps could be compared to the point data with all reports. This was done to help rule out likely areas of false reports and determine the best geographic location to find Bigfoot. So let's look at the results. The first two maps simply show the points where Bigfoot has been reported in the springtime. One map for all reports and another for only Class A reports. If Class A reports are actual reports of direct sightings of Bigfoot, while Classes B and C are indirect, one would expect there to be far more error associated with Classes B and C. Likewise, one would logically expect a different spatial distribution of Class A springtime reports than that of the dataset containing all reports. However, comparing the spatial distribution of all springtime Bigfoot reports to only Class A springtime Bigfoot reports reveals the exact opposite. That is, the spatial distribution of Class A springtime reports appears to be the same as the distribution of all reports. An easy way to show this visually is by comparing the standard deviational ellipse of both datasets. If the distribution of spatial points of Class A reports is different from the distribution of spatial points of all reports, then it would have a much different standard deviational ellipse. The directionality of the ellipse would be different and the size of the ellipse would be different. Instead, the ellipses practically overlap each other, strongly indicating that they come from the same distribution, especially considering that the ellipses are based on only one standard deviation. Nearly identical distributions between these datasets could mean one of three things. The first possibility is that there is far less error in Class B and Class C reports than expected. In fact, Class B and C records would need to be identical to the amount of error contained in the Class A records if it has an identical spatial distribution. Another possibility is that all classes share a similar distribution because Bigfoot doesn't exist and they're all false reports. The third possibility is that Bigfoot exists, but that the majority of the records are false sightings. If there's only a small number of actual Bigfoot encounters in the dataset, then it's possible that their inclusion does not skew the standard deviation or mean. Since the mean is more susceptible to outliers, I compared the mean geographic centers of the data with only Class A reports to the data that included all classes. Assuming that Bigfoot exists and given a priori knowledge of Class A, Class B, and Class C records, it's unlikely that these different categories of Bigfoot reports would have the same amount of error. Since Class A has a nearly identical distribution when compared to the dataset containing all records, logic dictates ruling out the first possibility. In other words, the data shows that either Bigfoot doesn't exist or that the majority of reports are false positives and that the few actual sightings do not skew the distribution. Again, assuming Bigfoot actually exists, it's almost certain that only a small number of reports in these records are actual sightings. Unfortunately, it's difficult to tell which entries would represent actual sightings of Bigfoot, but my best guess is that they would be outliers that are clustered in specific regions. Oddly enough, that's exactly what the outlier, cluster, and hotspot analyses show. So, if I were looking for Bigfoot, the most likely place to look would be in the northwestern portion of the United States, deep in the forest. I'll do a similar analysis for the remaining seasons in the near future. Do you think that Bigfoot exists? Let me know in the comments section. If you like this video, please show your support by subscribing. That's all the time I have for now. Thanks for your time.